Mr. D here, just checking in with some more calculus help as it relates to finding derivatives. So in this question here, we're given a function in the form of a rational expression, a binomial divided by a binomial, and we're asked to find its first derivative. So up until this point, we have explored the power rule for derivatives, chain rule, and the product rule. Those are the tools we have at our disposal. So having said that, we would have to rewrite that fraction so it's no longer in fractional form. So we take the denominator and just kind of remove it so it's 1 over the denominator. And you may recall that when you have a denominator, it's the equivalent of having negative exponent to whatever the exponent is here. So there's a 1 understood there. So in this case here, it would basically be the exponent would be -1. So under that understanding, we can move on and do our product rule, where this would be u, this would be v, and then we set our parameters as such. So u equals the first term, or excuse me, the first binomial, and v would equal this second portion with the exponent -1. And then we go ahead and using power rules, we take the derivative of x cubed and the derivative of -3x, and we come up with this. And then this one here is a little more intricate. We take the -1 down, less 1 from the exponent, keeping the base the same. And then we multiply by the derivative of what's in the base. So in this case here, we have a 4, which is a constant, so that's derivative 0. And then the derivative of -5x squared is -10x. So that's the chain rule, as I've noted there. And then we could do a little housekeeping. And we have a negative and a negative, and I just rewrote it as +10x times this quantity here. From prior learning, we noticed that the product rule is basically the derivative of the first portion, right here, times the second as it is, plus the derivative of the second portion times the first as it is. And because we set the table so nicely in here, we can extract and substitute the values and come up with this, just the basic substitution using these 4 values. So from there, it's basically housekeeping. The calculus is done. Now it's just a matter of tidying up the negative exponents. So we return them to the denominator, and we come up with the 4 minus 5x squared to the -1 goes down in this denominator, and the same here with the exponent -2 comes down here with the exponent becoming +2. Find a common denominator of exponent 2. So you multiply by a fancy version of 1. That's what I like to call it. So this right here basically is something divided by itself, which is basically just 1 whole. So that doesn't impact the question at all, other than it helps us find a common denominator to simplify this expression. And then from there, keep the denominator as 4 minus 5x squared, and then just write the numerators as they appear. You can expand and simplify the numerator should you wish, but I'm comfortable leaving it like that for our product rule interpretation of this solution. The scope of this video, however, isn't just the product rule. To review that, we're actually looking to go one step further to hopefully find another manner with which to handle quotients. So we're going to just move ahead to the next slide. We have the exact same question, asked the exact same way. Now what we're going to try to do is implement a new rule called the quotient rule, which is a fancy word for fraction. So if you have a fraction as a function, then you could let the numerator be u and the denominator be v, and you do what you did before. You set the table by taking the derivative of each just off to the side. So this is kind of like, some people call this rough work or work off to the side. At any rate, it supports the full solution and doesn't clutter it. So we take the derivative of the numerator, And in this case here, we take the derivative of the denominator as it appears. No need to rewrite it. We just take the derivative as it appears. Then, and this is the part that we haven't learned, this is what's called the quotient rule, where to find the derivative of a quotient, in other words, of a fraction, you take the derivative of the numerator and multiply it by the denominator in its original form, minus the derivative of the bottom times the numerator in its original form, and that's all divided by the denominator squared. So we're just going to go ahead and substitute that using this help that we've already done earlier. And then we proceed to substitute, and we have a negative times a negative here, and I just made it into positive. And if you look closely, you'll recognize this. What do I mean by that? Well, basically, if we go back a slide, you'll see that this particular derivative, I could just paste that there. I think I know what the problem is. Let's try that. You'll see that we have the exact same end result. So I hope that helps. That video was to highlight the quotient rule and relate it to the product rule. Should you encounter a quotient rule, a question that has a quotient, you have two choices basically. You can choose to use the quotient rule as it appears here, or you can rewrite the fraction as a product and apply the product rule, should you wish. Hope that helps.